Hi, I'm Dean Bushmiller with Expanding Security, and this is Defense in Depth. Use or consumption of this material by AI is expressly forbidden. So let's get started. For Defense in Depth, I know what you're saying. You're saying, I have a firewall. And that's usually what you hear is, I have a firewall. That only solves one problem. You've got lots of problems. No, really, you've got lots of problems. But you have many different attackers coming at you from different ways. And so there's the problem with I have a firewall, a single tool that we're using. If we're looking at defense in depth and we want to be really particular about it, we need a definition here. First off, it is a strategy. It's not a thing that you can buy. It's something that you incorporate into the organization as best you possibly can. And I'll explain the components of it in just a minute. But the definition is the application of multiple mechanisms to achieve security objectives. What kind of mechanisms? Controls. Usually those are technology controls, but they don't have to be. We want to layer heterogeneous security technologies between common attack vectors and assets. So this is the evildoer coming from the outside. This is the asset, and we put something in the middle, okay? Why? Because that ensures that attacks missed by one technology are caught by another. So there's defense in depth. It's a strategy. Where does this fit into our overall process? Starting with risk management, then we do a risk assessment, and then we choose to do mitigations. We choose controls. And we say when we're choosing those controls, we're not just going to have a firewall because it solves the problem. We're going to choose a strategy. That strategy is defense in depth, but it also has approaches within it that we'll discuss. And then you deploy controls. Once you've deployed the controls, you monitor. You're looking for all change. And that monitoring can come from above where the organization says, hey, Dean, we're doing things differently these days. Hey, we're buying this new company right here. We're doing this merger. We're selling off a piece of this business. That's a change. From the outside, it could be attackers doing things in a different way. They're using AI to attack us in this way, and we have to be ready for that. And we've got to change the way our controls work because of this. We're monitoring for all changes. And then what we're doing is we're tuning those controls. When we look at risk mitigation styles within this context, your mission is going to dictate the attributes that you want to protect and your priorities. What do I mean by that? Well, first off, let me ask the question, are we doing rational control deployment? I want a firewall because it's nice and shiny and because the other people over there have got that firewall. I want an intrusion detection system because my buddy's got an intrusion detection. That's not rational. It happens all the time, and we have to be ready for it. If we're doing rational spending, then the budget spending indicates priority. Management says go over here because this is an important asset. Okay, that makes sense. When we look at the assets, they're going to have attributes. Those attributes are confidentiality, integrity, and availability. Those are the general attributes that we're trying to protect. And those controls will protect those attributes. The problem is that some controls are inappropriately used. Like for instance, data loss protection tools are designed to protect against insider mistakes. That's their primary function. They have an encryption component inside of them. Are they a confidentiality protector? No, they're not really designed for that, but they do for mistakes, so they're not the greatest in the world. If we have an insider that's their machine has been compromised by an external person and they decide that an external attacker decides, hey, what I'm going to do is I'm going to send this information out. I'm going to exfiltrate this information. And they go, I'm going to encrypt it first. The data loss protection tool will not protect because it cannot see. So some controls are better than others at addressing the assets, attribute requirements that we're trying to achieve within our organization. What kind of approaches can we have to defense in depth? And there are a variety of them out there. First, we'll start off with treat all assets the same. Okay, everybody's the same, it's okay. That means that we apply every control to every asset and we try to create a series of hurdles. We'll put the firewall, the VPN, the intrusion detection, antivirus, and the patch process in front of every single control. Dean, does that mean that if I'm sitting on the local area network, I have to go through the VPN in order to get to those assets? Well, if we were doing it in the perfect way, we would say, yes, you do. You have to go through the VPN even though you're on the local area network. Now, I know some of you are saying, Dean, that's dumb. That's not the way to go. I know, but that's what you said. Okay, so let's move on from there. And also, this might be too expensive. You might not be able to have intrusion detection against every single asset that's in your environment because you can't afford it. Okay. So if we can't treat them all the same, maybe we deploy based upon the classification. Secret, top secret. It could be intellectual property. It could be research and development. It could be sales. It could be PCI. We'll deploy based upon the classification. In that instance, what happens is the mission critical assets, they get most of the controls. That also means that the non-critical assets, they kind of get starved out at that point. Not a bad strategy, not an awful strategy. It happens all the time. What we could do, and what I think you should do as an engineer of system security, is customize the controls based upon either the asset attributes, asset delivery protocols, vectors of attack, or the attacker tactics. I don't know which one of those works well for you, but that's what we're going to discover in the next 20 or 30 minutes together. Let's talk about the attacker versus the control. So here's the scenario. An attacker walks into a bar. No, I'm sorry. An attacker walks into a building, sits down at a terminal. They're logged in. That terminal's already logged in. There's nobody sitting there. They copy files to a USB, and then they perform a disk wipe against that machine. They light a fire in the trash can and leave the building. They're trying to go ahead and distract people. So everybody's looking at the fire over there, and they walk out the door there. We need to put some controls in place, right? But let's look at how these controls may or may not help us. First off, we'll start off with access control systems. Mandatory, discretionary, and role-based access control. Well, see, the person was logged into the system and they walked away, so none of these controls are going to help. Well, maybe mandatory access control, because we can say in the mandatory access control policy, no USB drives are inserted. So that might work, but it won't work discretionary and role-based access control because they don't look at those kinds of constructs within the system. Maybe if you put in an Active Directory policy, discretionary access control would stop all USB, but role-based access control, absolutely not. Okay. So we're going to choose one of those two right there and tune those controls. Authentication systems, passwords, tokens, and biometrics. Well, they're already logged into the system. Does the token do reauthentication? Does the biometrics do reauthentication at certain instances? I know when I was talking about the tokens that you use for YubiKey, they have a little resistance tap on them, and you have to tap it every once in a while to go ahead and say, I'm still here, use my passwords, or every time I go to authenticate something, tap, tap, tap. If it was set up and configured correctly, then that would do it. But the other ones won't do it because users already logged in the system. Okay, now backup systems. We could do a local copy, a redundant drive, or a mutable cloud store. Let's see. They inserted the USB drive, they found the files on there, they pulled the files off, and then they wiped. So a local copy, if they wipe the disk drive, that won't work. If we have redundant drives on the local machine, that won't work because wiping one drive will wipe the other. A mutable cloud storage. Was there a copy taken before somebody went in and whacked the drive? How about a door lock? Well, wait a minute, Dean. You're talking about cybersecurity. You're not talking about technology here, but here's the rule. If you do not have physical control over the assets, you lose. Full stop. Okay, so what kind of door lock can we use? A deadbolt, a badge, a cipher lock. All three of those would be great. If you couldn't walk into the building, then you'd have to also do something else. So you can see that these would work. Badges would be the best, all those stinking badges. We could use intrusion detection. We could use CCTV and guard. They see somebody got up from the seat and they see a stranger going in. That one will work really well. We could use snort, an intrusion detection system at the packet level. Nope, because everything was done locally. We could use particulate matter sensors. Really? Yeah, we could. When you light the fire in the trash can, a PM sensor will actually smell the smoke. That's what the PM sensors do. Smell the smoke, and they could, take action at that point or report in. Which one of these controls and which of these controls is going to work well depends upon your strategy, but you need all of these different tools in varying degrees for your organization. This is just a sample set of controls because there's many, many more controls that are out there. What are those controls? How do we organize those controls? That happens in a control matrix. That's nothing more than a collection of controls. It's organized in a particular way, and that allows you to go down the list and go, yep, got that one, got that one, got that one, got that one, got that one. And we can move on, right? So defense in depth is, what is our control deployment strategy? How do we organize the controls? And how do we know that we're doing it right? And that's what we'll cover in the next section. This methodology is mostly on the technical side, but we have to start from what I call zero. Bad information. In the absence of clear information, here's what we do. We capture historical data. That will work for us. And so what we'll do is we'll collect the risk management actions over a period of time. By the way, this will tell us what the risk appetite for the organization is. So how were the decisions made in the past? Was it ad hoc? And that's usually in small organizations, that's how it gets done. We have a firewall, somebody, we're going to take credit cards. Okay, well, then the PCI says we have to have the firewall. Okay, well, we already got that one. We need this, and this list of 12 controls right here, and we've got to put them all in place. Okay, we're good. Compliance required. It could be PCI, like credit cards, and then maybe you start taking credit cards overseas in the EU, so you have to apply to GDPR and make sure that you're following that. You all of a sudden take hospital payments. I don't know why you would do both of these things, but let's pretend that you do. Then you got to follow up with high tech. So compliance would force you into this thing. That would be the history there. You could be imposing a control process on yourself. Something like COBIT would do that for you. Or you could say, we want to do system security engineering. Very different way to approach controls and defense in depth. We'll talk about that in the end of the section. Okay, so now what we do is we collect and record the rationales by the organization. Why did you buy that? Because it was pretty and it was red and firewalls are red and that's the one I liked. Okay. It was required by regulations. Okay. Because we want to be more secure. Different. Okay. Fine. But collecting and recording all those rationales, you collect all that stuff up, and then you say, okay, was the decision effective or not? And normally what you would do is you would present your findings if you're at that senior level within the organization. And you could say, when we spent last time, was the expected outcome achieved? This is what we got. Is that what we expected? And this ties us back into the rationale. Management said we like it because it's red. Well, is it still red? Yeah, okay, well then that's no problem. We like it because it's a firewall and our buddy got one of these things. Is that a reasonable way to make decisions about firewalls? I mean, you really can't ask that question, but you get the idea. But it'll shine a light on because my buddy got one of these, and it'll kind of eliminate that pretty quickly within the organization. So that's your start to your methodology. We're going to dig into a couple deeper aspects in just a moment. You've got to pick a list of controls to work with. You've got to organize those controls, and those are control matrices. Here's the problem. when you go to read, and I was just reading today, I was reading a book that is about 5 years old. So this is February 2026. So therefore it was written in 2021, and they used some terms in there that gave me the shivers. And the first term that they used in there was safeguards. These are the safeguards that will protect you. The reason why we can't really use this is because it means before the fact. And there's many other things that are after the fact. You go, oh, well, wait a minute, Dean. It also said in the same book, it said countermeasures. And that's after the fact. They don't mean that. They mean control. And they're not organizing them. They think, people who write this way, controls and countermeasures are the same thing. They're not. You have to go back to a document that was about, at this point, is written in 1997, so almost 30 years old to see those terms and their definitions. They have no meaning today. Okay, Dean, well, what should we use? Well, when we're organizing our controls, and this I went and typed into Gemini, I typed in, give me the list of control types that are out there, or tell me how to organize my controls so I can talk and make sure I don't miss anything. And it said administrative, technical, and physical. Well, again, that's in a document that's going on 20 years old at this point. It's not nearly as sophisticated as we need to be today. How do we organize controls today? Typically, if you work with like a CISSP or somebody who has SecureX or kind of a high-level certification, they'll talk about the categories of controls. And here we're talking about preventive, detective, deterrent, corrective, directive, and recovery controls. Whatever the controls are, we organize them and we put them into those slots. So what we do is we say, oh, well, we've covered all of these things, but we haven't covered that one. We've gotten corrective controls in place, but we don't have any policies in place to go ahead and tell people what they shouldn't be doing. So we're going to need to put in some policies in place. Oh, we've already got policies, but there's no work from home policy. Oh, we need to put that policy in place. We categorize those controls, or we organize those controls. There are other ways to do this. If you're in the U.S. military or government, there is a document called Special Publication 853, and it has families of controls. And there are 20 families of controls. That's a lot. And that may be that you have to do that. And what you do is you say, do I have controls in each one of these? Tick, 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 tick. This might be hard for your organization to understand, and it's important that the organization understands this. And then you could use something like mine, and that's called paramedic. And, you know, it doesn't matter how you do this. This is the way that I do it, and if you're interested in that way, you can look at one of my other recordings. Actually, in engineering, I talk about this, but it doesn't matter. Pick one of these organizational categorization tools for your controls so that you can see you have complete coverage, defense in depth. So then your job is to go ahead and learn that, learn all the definitions that are there. Build it into your documentation for your organization. And here's the key. You need to teach everybody this organization system so that when they say, hey, I want to buy controls, they don't just go out and buy another firewall. They go, what controls should we buy now? By the way, they don't do that. We do a risk assessment, we do risk management, and then we come back and say, here's our holes. And they go, oh, I understand why we have these holes and why it's important to fill those holes, because defense in depth. Something that you won't see many other places is what I call asset delivery protocols. So what I do is I distinguish the protocols that we use. So how is the business function being delivered? What's the protocol that we're using to deliver that? Because this gets into our risk assessment control issues that we run into every once in a while. The asset delivery attack surface is not the asset. The asset is the data. But how that flows, how that's stored, that becomes a component of our review and our risk assessment. So what you can do is you can ask, does this have its own operating system. Like routers and switches have their own operating system. Does this need to be patched? Well, there's firmware updates and software updates. And if we're doing software-defined networking, then we have a management plane and a control plane. So yes. See, what we do normally is we attack and secure this as part of the asset delivery surface, but we don't call it the asset. It's how it gets done. And we need to do that because we're going to separate this out and it's going to create the layers first. We're going to go all the way back to the OSI layers. No, not really, but we're going to go back to layers. We need to separate the vendor implementation from the protocol that's actually used. See, if the IETF has a problem with the protocol design, then all vendors and all organizations have a problem. An example of this would be the Kaminsky DNS cache poisoning attack. He didn't do the attack. He found out that there was a cache poisoning problem. It was a problem with the protocol. It was a problem with DNS. And the ability to randomize was based upon a fixed small number. It was a big number when we started the internet, and so it was a reasonable tool to use for DNS caching in the 60s, 70s, and 80s, but it isn't. And so, rest in peace, Kaminsky, you figured it out. But that's separate from if the vendor has a problem with their implementation. If you buy Microsoft products and Microsoft have a problem, only organizations that use that software have that problem. Even though it may be the DNS protocol, it could be something like CVE 2024-26221, Windows DNS Server Remote Execution Code Vulnerability. See, it's a DNS problem, but it's a DNS problem with that vendor. Okay, so let's step away from that and let's look at the asset delivery protocols. Let me give you some examples here. I have an entire section on this in the engineering, so I'm only going to give brief examples here. You'll see them in black. From a connectivity standpoint, the router runs BGP. That's a protocol, and it represents a problem to us if we've misconfigured it or if the vendor that we purchased it from, with Cisco's version of BGP and they have a problem with their implementation. But BGP is the protocol. Wireless, WPA2. I know we're at WPA3 and beyond at this point, but you can see where that's an encryption protocol that we have to deal with. On the client side of things, bring your own device. It's an operating system. It's not really a protocol at that point, but we have a multitude of operating systems. We have lots of mobile devices that we have to secure at this point, not protocols. Dean, where are the protocols? Okay, on the server side of things, when we talk about the delivery of assets and collaboration, email, SMTP. Video, the codec for that is H.264. Voice, we have VoIP. It has its own vulnerabilities. The protocol has a problem. It's delivering a particular asset, which is our conversation. We could even deal with storage. Like on NASs, we have NSF, or storage area networks, we have fiber channel over Ethernet. We have to protect that particular service by doing something else, like encapsulating inside of encryption. We also have the support of assets, like print, we might have IPP or CUPS or something like that. For our infrastructure, we have directory services, the LDAP protocol, dynamic IP address assignment like DHCP or maybe even APIPA. We have resolution services like DNS and ARP. We have to secure those. And for databases, we might have SQL or PSQL. It depends on what kind of database that you've got out there. So we've got a list of protocols that we're paying attention to. Let's come on over here to governance just for a moment in time. In defense in depth, when do we put new controls in place? That's when the appetite for risk changes in the organization. You cannot ask, what is your appetite for risk? Because they don't know, and it's a bad question. But you're trying to collect that up over a long period of time. So what you do is you do a business interview. So we would ask questions, and we have to be careful about this and explain this is all part of our understanding of the risk management and risk assessment process. Know where you are in the stack. In the business interview, we would say, what business are we in? Well, you should know that because this is our mission. Yeah, okay, that's fine. What data do we collect? What do we do with that data once we get it? if we lost blank, we are out of business. Please fill in the blank. And they would say, oh, well, this business asset right here and the way that gets delivered. Mail is the most important thing for us. I don't know. In our organization, who initiates a risk assessment? How often is it done? Today, you will get lip service within the organization that says, we do continual risk assessment. Okay, fine. We'll come back to that in a second. Who will read the final report or the continual reports that we have? What actions will be taken because of this report? How will it affect change? And here's the big one. Who can increase or decrease the amount of money spent for controls? And they'll say, well, you have complete autonomy at this point. No. If all of a sudden there's a change in the business and they say, we've got to spend this money on, like right now, as of 2026, we've got to take all this money away from here and we've got to give it to all of our new AI group, right? Who's that person? Who's that person that grabs that money and goes, no, you can't buy firewalls. No, you're not going to be able to upgrade from silver to platinum. In fact, you're not going to get any support whatsoever for any of your stuff this year. Give me all that money. And that person, that's the person we want to know. That's at the governance level, and you may not be at that level in your organization, but you could collect this information over time to understand the risk appetite for the organization, how they make decisions, how logical this is. Sometimes you get a lot of lip service because you're really far down in the stack, but as you move up the stack, you'll get a more clear understanding of this. So that's governance, and we're going to switch over to risk next. For risk, we want to do a generalized process here and understand how this process is going to affect defense in depth. So we start off with a new business, first version, no data, right? And that's where we go. And what we're going to do is we're going to build maturity measures, build a budget, build a communication process, and populate our asset list so that we understand what data is important to the organization. Then what we're going to do is we're going to collect up the required controls. There are going to be some, like externally we've got regulations, or it may be based upon this business type, we have to do this thing. There are requirements because we're an engineering firm, and therefore we have to have these controls in place because we can't have our engineering design drawings edited in a way that would cause physical harm to people. Then we build or choose a controls matrix. That's just like we showed you before. It's just a list of controls. That may be organized into a particular framework that we have within our organization. This could even be system security engineering. It depends on the organization and how they do things, but they'll have an architecture framework that they work within. Or they may not, and you might bring it in. What we'll do is we'll organize. We'll map the controls to the assets. This control is protecting this asset. The control is going to be applied to everyone, all the assets. And that solves the high business level problem. What we could do is we could carve off, and this happens in the military when they say, we have controls at this point, and when you go down lower, you don't get to choose the controls that are up above, you get to choose these controls. And we go lower, and you get to choose these controls because you're inheriting controls from above. An example of this would be policy, and this policy has to fit the organization. You can't just blanket grab policy documents, find and replace inside of those documents and be fine with it. Because let's say that we have a policy that says no guns at work. Dean, that seems pretty logical. We can't have any guns at work. I mean, that's, threatening life safety here. Well, it's not going to work in a gun factory. Or no drinking alcohol at work. That's a reasonable thing for us to do. But if you work in a vineyard, that doesn't work. So we have to tune the policies to the organization and the controls to the organization. What we would like, we don't get this all the time, is to write the owner rationale. Write the rules for exceptions also. So why do they do it, and how do they say the rules don't apply in this place? You might collect that over a period of time like we did in the methodology section. It might not work well for certain organizations that are in ad hoc mode. You can bring them back by giving them this process or using a risk assessment process like Riot to go ahead and get them in the correct place. See risk assessment video recordings that I talked about before. Okay, so then what we do is we apply the controls to the specific assets. This doesn't matter to those people. It does matter to these people. We put the controls in there, and we have to engineer and organize our technical stuff so that you'll have to pass through that particular control. So then we deploy the controls, we configure them, we update them, and we log all the outputs to our monitoring tool. When we collect the data, we're doing a technical risk assessment process, but we're doing some other things in here. We're connecting this to the matrix to automate the collection tools that we have. We're looking at our risk tolerance. We can't ask for what that is. That risk tolerance could be static or it could be dynamic. It could change over time. It depends on the kind of business. In that risk tolerance, we're going to take inputs of looking at insurance, like can the organization do its own insurance? Can it buy insurance? A lot of times today, organizations are doing ransomware insurance and thinking that that will protect them in all cases. That we'll just buy insurance, we've got a firewall, we're good. There's lots of exceptions in those. They also may do it on asset valuation methodology. I don't know what that looks like for you, but they're going to say this is more important to us. This is the ranking process. We're going to collect all that business data, all those flows, and bring them together. And then we're going to put them in some way, we're going to automate this into an output dashboard so that everybody can see what's going on. That's generally called monitoring. If you read monitoring reports on a weekly basis, risk assessment reports on a weekly basis, and your manager reads those kinds of reports, and your manager's manager and the CEO of the organization reads those reports, you're doing continuous monitoring. But if it happens when we have board meetings that we have to go ahead and review all of this stuff and it happens on a quarterly basis, not continuous. You're collecting the data continually, you're just not acting on the data continually based upon the changes in business. So what we do is we build input and output views based upon each role and each level in the organization because we are doing continuous monitoring. And that's a great way to be. But this is only one way to be. Technical organizations may do this completely different. Let's look at that next. So I want to talk about the attack process, not attacking you. Okay, I want to talk about MITRE's attack. In MITRE's attack, what they say is we're going to do tactics-based control selection. So we're going to look at the adversaries, we're going to see how they do things, and we're going to look at their tactics, and we're going to select controls based upon that. Instead of doing asset-based control selection, this is a way to go. Some organizations are doing it. Dean, what are the tactics? I'm going to open this up and then we're going to come right back inside of here. Here's a list of the high level of tactics that are going on. I'm going to click on just initial access for a second, and I want you to look over there and you'll see it says enterprise right now. I could go down and look at mobile tactics because they're different. I could look at industrial control systems because they're different. Let's go to the enterprise because that's where we live. We're going to look at initial access. For initial access inside the enterprise, usually we're talking about computing infrastructure for us, right? How many different initial access techniques are there? So the tactic is initial access, and this goes on and on and on. So for Wi-Fi networks, we drill down into that and we look at the tactics, what they do. We read the tactics and say, yeah, we do Wi-Fi in our organization. We're probably susceptible to this. And what we can do is we can do these mitigations right here, or we can do these detection strategies right here. Let's go back and look at the different tactics and get a handle on this and just think through, okay, how would I address that particular tactic? At the highest level, reconnaissance. They're going to gather information to plan future operations. Well, I'm going to have to hide that information from the internet, make sure that it's not available. Probably unlikely, but okay. Resource development. They'll establish resources to support operations. They may establish resources like getting people, convincing them through social engineering long term. They may go to our suppliers and connect to our suppliers and compromise them because we've got lots of controls in place, but the supplier that we use doesn't. That happens like HVAC companies. Initial access. They get into our network. Well, we have a firewall and it'll stop all that. Probably not, because you don't have a firewall everywhere on every device, especially your mobile devices. Then they do execution. That's running some sort of malicious code. Hey, we've got antivirus. That should take care of that. Not all the time, and you're going to see. They perform persistence, which means that they maintain their foothold within our organization. The average time to recognition of an adversary in your operations globally, I think it's 200 days. In other words, they got in, they're hanging out, they're playing, they've set up a tent, they've installed a hammock, and they've done all of these things. And 200 days later, you go, hey, they're in here. They've maintained a foothold. Privilege escalation. While they got there, they gained higher level permissions within our organization. Maybe they came in as a guest, then they got a user account, then they got an administrator account, they got system or root. They do defense evasion. We've got controls in place. We've got intrusion detection. We've got snort. And what they do is they try to avoid being detected. And there are many ways that they do that. Then they'll do credential access. And this is where these kind of all loop together. They don't just do this in one straight line. They keep on looping from one thing to the other, and they keep on going back and forth. But they could steal account names and passwords. So if they got in as a guest and as a regular user, and they didn't have any access to anything, they all of a sudden they saw a file that said, usernames and passwords of employees that always forget their passwords. Please note these accounts right here. Static passwords, API keys, something like that. It'll be on that workstation, and they get in and they steal that stuff, and then they go back up and they loop through everything that they're doing. Next, they'll do some sort of discovery, figuring out the environment. They'll look at routing tables. They'll look at our routers. They'll look at our switching infrastructure. They'll look at the ARP cache that they may be able to communicate with. They'll figure out the environment. If they can get a hold of an SNMP server, that's really kind of the gold. Lateral movement. They'll move throughout the environment. Sometimes this is called pivoting, where we move from one machine to another machine. Collection. Gather that data of interest to their particular goal within their assets. Command and control. That's communicate with the compromised systems to control them. This, again, can happen at multitudes of layers. And then exfiltration. They'll just steal the data. So those are the tactics, the general tactics of our adversaries. And what we can do is we can say, okay, well, we want to put up mitigations. We can go straight to the mitigations themselves. We can go to the mitigations and we can say, okay, we want to protect against the threat of account use policies. I mean, we want to protect ourselves against this particular threat, and here's how we'll do it, and here's a description of how to get that in place. Now, you'll notice over on the right-hand side, it has the long list of all the different mitigations that you can put in place. So you could skip over reviewing what the tactics were and work your way through this entire list and put all these mitigations in place, and this would be your controls matrix. But you're not done yet, because you could also do this through detection. Here are your detection strategies. Look over in the corner, notice that we've got enterprise, mobile, and industrial control systems. Now, some of these may give you a twofer. It'll work on your mobile, it'll work on your enterprise, and that's fine. But how do you detect these things? How do you put controls in place to listen for this? These are reasonable tools to put in place for some of you, but they're very narrow in scope. I've seen organizations that do it this way. They say, this is our list of tactics of the adversaries that are going after us, and we're going to build mitigations and detection controls in place to protect against those particular things. They're very specific and very surgical about this. I don't know if that'll work for you, but that's one way to do things. In our operations process, we ask the question, how are we doing? Because we want to know if this is working. We've chosen all these things. How do we do that? Well, we collect periodic risk data. An example of this would be, in this case, let me slide this up a little bit for you. We have 10 assets on 30 computers with 10 critical patches unpatched and 10 non-critical patches unpatched. So what we have is we've got the assets, the computers, the unpatched, and the patch, and we create this matrix for ourselves. That means that the total possible patches in this case, and these are fictional numbers, are 25,000 patches. Total patches applied, 24,500. That means that there's 500 outstanding patches. But remember, not all computers require all patches. So we have to keep that in mind, and we have to teach that to people as we're working along through this. And what we want to do is we want to compare two periods. So we'll say in period one, or it could be multiple periods. In period one, we've got 10 assets, and it goes 10 equals 30, 10, 10, right? Next period, we've got more assets, we've got more computers, but our patches for our critical have gone down and our non-critical patches have gone up. In other words, we worked on the things that were really important for us and we let the other things go. But we've got 35 new computers, so that means that we probably have more patching that we have to do. Let's go to period 3 or period whatever. At this point, still the 35 computers that are there. Critical patches unpatched went from 5 down to 2, but non-critical patches went up from 20 to 40. And we calculate this way. Now, this is just a back of the envelope kind of calculation, but you're looking for change that you can calculate on. You're looking for comparisons so that you can answer the question, how are we doing operationally? Then you could take those overall failures there and you could look at the long-term failures for your organizations. All your computers are going to need patches. You know that's going to happen. But where is the cluster of threats within this patching? Because we buy a lot of this product from this vendor and a lot of that product from that vendor and a lot of product from that vendor there. And the commonality between all three of those things is a cluster of vulnerabilities. Like an example would be lots of computer software that we purchase has authentication failures. Can you think of a control that we would put in place? Because can we fix this systemically? The management question is, how can we fix this dense cluster of threats and vulnerabilities? They're not going to ask that question, but you can train them to ask that question. And the technical answer would be, we can use multi-factors or tokens across all devices to reduce authentication threats and vulnerabilities. You're doing this at an engineering level. You're looking at the history and you're saying, how can we be better? Generally, this is a risk management technique. And so we ask this question, will this fix across many assets limit future vulnerabilities or threats from being realized in our environment? Well, we're going to buy more of that product in the future, and that product sucks at authentication, so multi-factor is the way to go, and it should protect us. It may not protect us on that particular setup because it doesn't have multi-factor authentication, but let's go back to the tactics for a second. Somebody could pivot. They could get in here and then try to go around and go after this asset here, but because multi-factor works here, doesn't work here, they're going to run into that, they're going to run into that wall on that side. We collect these risk management actions over time. And then we ask the question, when we spent last time, was the expected outcome of lower risk actually achieved within our organization? This turns it into a rationale. This converts, I want it because it's red, to I want it because it's going to help us from a business standpoint. Briefly in system security engineering, I wanted to dip our toe in here. I do have a whole recording around system security engineering, but I wanted to say, how does system security engineering change the way we do defense in depth? because it is a radical shift. We start off with the business alignment. What does the business want? What is its rationale? In our architectural design, we'll say we're going to integrate security controls into the design of that thing. An example would be in our requirements analysis, we're going to integrate security controls into the requirements based on these asset classifications so that we can only process data through that particular control. It's functionally incapable of processing data without passing through that control. It's functionally impossible to circumvent the control. We do that at a design level, at an architecture, at an engineering level. What do we have to do to follow up on that and make that work? We have to do the verification. That means that we have to design a testing procedure for the controls designed. See, it's not the mission that we're trying to achieve with this new application. It's the control on this piece of the mission. We have to make sure that the test works and shows that it works. Then what we need to do is we need to validate this by testing the procedure, doing the actual execution of it, and then reviewing our test outputs. This is a very different way to do defense in depth because what we're doing is eliminating problems at their source. It requires a big mental shift in organizations. Why do defense in depth? Well, it's very simple. For me, when I look at it, what I say is we're reducing risk to an acceptable level. I hope you enjoyed Defense in Depth, and I'll see you soon in another video.